my name is Tom, and today we're looking at intramolecular forces and potential energy. Which bond of the following is the shortest? So the shortest would be triple bonds. The strongest would also be triple bonds. The weakest would be single bonds. And the longest would also be single bonds. Now the reason for this is because a single bond doesn't have as many attachments, so it's going to be longer. It's like if you're grabbing onto something with your arm, it's obviously going to be longer than if you were to grab onto it with two arms. Get a little closer. If you try to grab onto it with your leg, then you're going to have to get even closer. So the single ends up being the longest, with the triple being the closest, but the triple being the strongest and the single being the weakest. Alright, for this problem, we need to figure out where the bond is at its most stable. So it is at its most stable at this point here, at the trough. That is where the bond is always going to be stable in these graphs. Put a little X there. Now we need to mark on the x-axis what is the distance from each nucleus. So here would be the distance. We just mark up from that point that we put earlier. Now on the y-axis, we need to put the bond energy of the bond, or how much energy it requires to break that bond. So again, we just mark over to the y-axis, a little X there. Now, the problem wants us to draw, if this line here were representing a single bond, what a double bond would look like. So, all we have to do is draw a line from here down, goes deeper like that. So notice how the bond energy is greater and the internuclear distance is lesser, which is what we would expect from a double bond and what they would look for on